Hi, my name is Gaz. I'm a technical engineer here at Maxon, UK and Ireland. And in today's video, we'll be looking at thermal operating ranges. And to my right, you can see a typical operating range diagram. And on that diagram, in the red shaded area, is the continuous operating range. And to the right of that is the short-term operating range. And what else you can see on there is the max permissible speed and also the continuous torque. So if we look at the permanent operating range, this is the red shaded area on the graph to my right. Within this range, you can run a motor continuously without any issues. The only limiting factors being the maximum permissible speed and the maximum continuous torque. When operating your application within this range, it is not thermally critical. Now let's look at short-term operating range. This can be seen in the white area on the diagram to my right. As you can see, this is not defined. This is down to your application needs, motor requirements, and surrounding ambient conditions. In general, a motor can only be run to its continuous current limit. This is due to thermal restrictions. If you've seen our previous video, you'll understand the relationship between current and torque. Higher currents can be applied to a motor, which will produce higher torque, and in turn heat up the winding. It is important that the winding temperature does not exceed its limit, as this can lead to permanent damage to the winding. There are limits to how much a motor can be pushed, and this can be found in line 19 of our datasheet, and this is the thermal time constant. How far can you push a motor? As you can see from the diagram, it gives you a rough idea of how much you can push one of our motors. How far you can push a motor depends on its construction and its size. Depending on whether it's a large motor or a small motor, the time you can push it will vary. Let's have a look at the diagram. To start off, you've got the red region, which is our continuous operating range, where you shouldn't see any issues running your motor as long as you're within the limits. Once we push into the white region, which is the short-term operating range, you'll see that you're limited to how much you can push the motor. So you can go as high as 5 times the thermal time constant, or 4 times the torque limit. If you were to go to 5 times the thermal time constant, you can see that you can only run the motor to maybe double the torque limit. But if you wanted to push the torque, you can go up to 4 times the torque limit, where you'll be restricted to the time that you can push this. So it'll be in just under 1 times the thermal time constant. And in some cases, it might be half or maybe even seconds that you can run. And looking beyond this, you've got a grey area, which is the forbidden thermal area. Within this region, you would require some sort of thermal dissipation. At this point, we'll have to review your application and also run further testing in order to see how much that motor can be pushed. Winding temperatures. Due to the winding resistance, the motor current increases the winding temperature. In order to prevent overheating, we must dissipate the heat via the stator into the atmosphere. The maximum winding temperature for maxon motors can be found in line 22 of our datasheets. The maxon DC brush motors and EC motors has a max winding temperature of 125 degrees, and in some cases up to 155 degrees. The precious metal brushes are low current motors, and the maximum winding temperature for these are 85 degrees. There are many methods in which heat can be dissipated. For example, mounting to a metal flange or forced air circulation, and this can significantly reduce the winding temperatures. Maximum permissible speed. The speed of a motor does not generate heat. The load that is applied to the motor is what generates the heat. When a motor is run at high speed or low speed, the heat generated is likely to be more or less the same. When you apply a load to this motor, that is when you're going to see an increase in heat. It is often misunderstood running a motor at high speeds is causing more heat, but actually when you apply that load at that high speed, that is what increases the heat generation. So it's important to know that the heat is generated by the load and not the speed. Thank you for watching. If you would like further information or application support, feel free to contact us.